All right, here's the second half of the midterm for Math 151. Um, this problem right here, although originally I had it said do both of them, I really only asked for one. A couple of you who took the test in the testing center didn't know that this part was crossed out. Well, I just didn't grade that part. I graded the part that I was doing for everybody else. So anyway, I've got the graph of the function here. I want to look at the graph of the derivative. Well, one thing I notice here is that it starts off going uphill and it's bending. Some people looked at this and said, you know, over 1 up 2, it starts off at 2. I want to suggest that maybe it starts off bigger than 2, because if this were a straight line, then okay, that's the slope of 2, but it's kind of bending downwards a little bit. So it must have started off higher and gotten less. I don't really care. It was up here somewhere. It started off at around positive 2 or maybe a little higher slope, right? And then the slope is getting smaller and smaller and smaller until, right, because it's getting less steep. So the slope is starting big, coming down to 0 right here. So just count it over. It's 1, 2, 3, 4 in. 1, 2, 3, 4 in is where you got to 0. And then it starts getting negative slopes. And it looks like there's some symmetry of however steep it was on this side. It's the same steepness but negative on the other side, and so it must be headed down down here somewhere, right? And if this was a 3, you know, anyway. I actually tried to draw this as a parabola, and so the derivative would be a straight line, but if you saw this maybe as part of a sine curve, then this might have looked more like a cosine curve. I didn't really care the shape of this. What I did care was, is it starting up high? Is it hitting 0 in the right place? Is it headed down negative? Now, the next thing I cared about is that at this point right here, there's a sharp corner. So actually, this should be an open circle on the end here, right? Because at the sharp corner, the derivative doesn't exist. Through this stretch right here, the slope is 0 the whole time. So the graph of the derivative should have a y value of 0 through that whole stretch, right? Because the y values of the derivative are telling you the slopes of the function that you started with. So all through that stretch, the slope is 0. So all through this stretch, the y value is 0. Again, there's a sharp corner right here. So at this point, the derivative doesn't exist. There's no value that you get out of the derivative. It doesn't. It's a sharp corner. The limit as h goes to 0 doesn't exist because the limit on the left-hand side is 0. The limit on the right-hand side is 1. And left-hand limit and right-hand limit are different. So anyway, what does happen is that it hops up to a slope of 1 through this whole stretch. That's a straight line through there. So through that whole stretch, there's a slope of 1. How far does it go over? 1, 2, 3, 4. So through there. Again, sharp corner. Suddenly, I've got this straight line going down with a slope of negative 2. So I'm down here at negative 2 for 1, 2, 3, again for 4 things going across. At this point, I tried to make it look like have a smooth transition. 1, 2, 3, 4. So it gets over here, and then has a smooth transition down to a slope of 0. Still, the slopes are all negative, but they're getting closer and closer to a slope of 0. So from here, it just kind of comes up to 0. Again, I didn't care quite what shape you made that as long as it started down here and ended up at 0. So I was looking for these open holes because at those sharp corners there's no derivative. I'm looking for the flat parts here with the different slopes of 0, 1, and negative 2. Looking for that downhill piece there. If you screwed this up, I mean, a good way to show me that you know how to do this is maybe draw another function. Draw something and show me how you would take that and turn it into its derivative. Okay, that would be a good way to convince me you know how to do this. Because I mean, I just did this one for you. So draw another function and do it. Okay. That's 10. Number 11. Okay, just take the derivative. This one most people did just fine. This is polynomial. Right, so y prime is 8x cubed plus 6x squared minus 10x. You know, if there was something you got wrong, sorry, plus 0. If there was something you got wrong within that, then explain to me what went wrong. Did you multiply 2 times 3 and get 5? Did you forget to drop the exponent by 1? What was it? and then explain why it has to be like this. I mean, maybe you got to use the definition and explain what is correct. I don't know. This one, quotient rule. This is a quotient, so you've got, you know, the bottom squared, the bottom times the derivative of the top. Derivative of the top is 3 plus e to the x minus the top times the derivative of the bottom, right? What did you do wrong? What went wrong? Was there some algebra that happened? Did you have a plus sign in here? If, you know, figure out what it is that was wrong and then explain why that was wrong, and show me the right thing. Did you cancel these things out when you shouldn't cancel out? I don't know. Number 13, there's several things that went wrong. First of all, there's some people that saw this as a product, right? This is not a product. This is the inverse tangent of 3x. Right? The next thing that people did wrong is they saw this as tangent to the minus 1 power. Okay, and tangent inverse of x is not equal to 1 over tangent x. Right? That would be equal to the cotangent x. This is a trig function. This takes an angle as an input and gives you a ratio of sides as an output. This is an inverse trig function. It takes a ratio of sides as an input and gives you an angle as an output. These are definitely not equal to each other. And I had people taking the derivative like it was the cotangent. It's an inverse trig function. So we do that several ways. There are some people that remembered that the derivative of the inverse tangent of x would be 1 over 1 plus x squared, right? And so in this case, you don't have an x, you have a u there, so it would be 1 over 1 plus u squared, then the chain rule would say times the derivative of u. So this would look like a 1 plus, 3x squared, that the 3x is being plugged in. So that's the derivative of the outside function, leaving the inside alone, right? The inside got used down here. I had some people do something like this. They would say 1 over 1 plus x squared, because that's the derivative of that, and then they'd leave the 3x here, and then the chain rule would be times 3. It's like, what the heck is that? I mean, that's a big old question mark. But to say leave the inside alone means the inside has got to go wherever the x is supposed to go. So when the derivative here is 1 over 1 plus x squared, that's the inside. That's what happened to the x. It got put right there. So that's what's happening to this 3x. It's being put where that x went, right? Now there's a chain rule that says multiply by the derivative of the inside. So then you got to multiply by 3. Okay. There are some people that did this by taking the tangent of both sides and implicitly differentiating like we did many times. That works just fine. But, if you made one of these mistakes, explain to me what's going on and why what you did is wrong and why this is right. Okay. 14. Similar problem here. Actually, there are a bunch of problems. But again, there's people that looked at this as like a product of sine cubed times this thing. So they're taking a product rule there. And it's like, well, what the heck is sine cubed as a function? Sine cubed doesn't even have an input. That's just the name of the function. It has no value at all. It has no, it's not a function. It's the name. It's like saying, I can think of functions called height. What's the height of your teacher? Well, 6'2", right? If I just said what's the height and didn't say of what, then it's meaningless, right? Function names need inputs in order to be complete. So anyway, this is the sine cubed of this thing. But then sine cubed is one that throws people off, because literally sine cubed means you got to take the sine of this stuff, 2x cubed plus 3, and when you're done, cube that. Right? So this has actually got two chain rules involved, because the outside function here is a cube of something. So you should have 3 times the stuff inside that set of parentheses squared, but then times the derivative of what's inside the parentheses. Well, what's inside the parentheses is the sine of something. The derivative of the sine of something is the cosine of that something. But then that wasn't just a cosine x, it was a cosine of something else. So now the chain rule says times the derivative of that, which is 3x squared. Right? That there's two chain rules here. You got to deal with the cube of something. So that's 3 times that something, all of that something squared, times the derivative of the inside. But that inside also has an inside, so then there's another chain rule that pops out. Okay. And I can't take the derivative here. 2x cubed should be a 6x squared, shouldn't it? Right there, 6x squared. And those are going to get together to be an 18 total. Okay. 15. 15 is a very similar one to these that, again, I saw people trying to do product rule there. I also saw people, they weren't doing product rule, but they're trying to take the derivative of the outside, leaving the inside alone, and they're doing something that looked like this. They're saying the derivative of the natural log is 1 over x, and then they're saying, oh, but then I still need a secant x there because I need to leave the inside alone. It's like, no, 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 this is wrong. The thing is, the derivative of the natural log of x is 1 over x. So what happened to the inside? The inside gets put down here in the denominator. So when I say what's the derivative of the natural log of secant of x, it's 1 over the secant of x. That's the derivative of the outside with the inside left alone. The inside is playing the role that x did there. It's instead of a log of x, it's a log of u, and so it's 1 over u here, and that's the u. But then the chain rule says multiply by the derivative of u, so I need the derivative of the inside now. The derivative of secant x is secant x tan x. Right? And it turns out the secants will cancel out there, but then you need the derivative of the hyperbolic cosine, which is plus the hyperbolic sine of x. Right? Hyperbolic cosine of x gives me hyperbolic sine of x. Those cancel out, whatever. There were some people who had a minus sign there. There were some people who converted this to the hyperbolic cosine. They converted it correctly to this. But then they took the derivative wrong, because although the derivative of e to the x is e to the x, the derivative of e to the minus x is e to the minus x times minus 1, and there's a lot of people that miss that minus 1, which would come here. So anyway, if you got that derivative wrong, show me how to do it correctly, and don't just tell me, oh, derivative hyperbolic cosine is hyperbolic sine. Show me to do it, very like this, take this derivative correctly, and say, oh, and then look at the definition of this thing was that. So I have, what, 3 more to do, and I'm going to run out for 15 minutes. So I'm going to make a third video for the last 3 problems here.